Station, this is Houston on Space to Ground 2. Are you ready for the event?
Houston, Station on 2, we're ready for the event.
YouTube Space Lab, this is Houston. Please call station for a voice check.
So, station, can you read us? This is Bill Nye at YouTube headquarters in London. Do you hear us?
We got you loud and here on the International Space Station. How you doing, Bill Nye, the science guy?
We're fabulous. You're looking great. It's very exciting. Can you just reassure us, that you really are in the space station? You're not suspended by hidden wires in a closet someplace. Maybe your hair alone kind of gives it away.
There would be a lot of wires holding my hair up right now if that was what it takes. But I guarantee you, we're up in space. I don't think, I'm not a gymnast, so in normal life, I don't think I can do this.
Wow, very nice, very nice.
Here I can do it. Here I can do it as a 10.
Slow motion. That was very nice. Well, really appreciate you taking time. Very nice. She stuck the landing. Very nice for taking time out of your schedule. You got a lot going on up there. I'd like to introduce you to a few people we have here back on Earth. We have the winners of the YouTube Space Lab competition. We have Dorothy and Sarah and Amr. Greetings, everybody. Greetings. Now, Sonny, you've been working on their experiments. I'm excited
to be here with you guys. I was happy to have met you guys in Washington, D.C., and congratulations. I think it's been a little bit of a whirlwind for you since that time, so I hope you're enjoying yourself, and we're enjoying your experiments up here, so thank you.
So you look very relaxed, and you set your microphone down. That's very nice. Or set your microphone up, or where is up. But what is a day like? I get the impression you guys are busy all the time.
Well, every day is different, and we are busy all the time. We have a general working day, same as time as you, GMT. But we usually get up around 6 and try to go to sleep around 10. But every day is different. We're doing science experiments. We're exercising. We're out doing spacewalks. We're doing robotic stuff. We just launched HTV, the Japanese module that was up here, left us yesterday. So it's one thing after another. Every day is a little bit different. It's awesome.
Now, spacewalks, launching Japanese modules, making scientific discoveries, that's routine. But you have any other stuff you have to do, like the laundry and dishes and things like that?
Well, luckily enough, most of our food is in containers, and then we throw it away, so we don't really have dishes up here. If you think about it, dishes aren't going to work up in space, so we just sort of eat our food out of different types of containers, so we don't have to do that. And there's not a lot of dirt up here, so your clothes don't get dirty for the most part.
What sort of food do you get to eat up there?
We have a wide variety of food, which is really great. Just in this in this little packet, I have beef fajitas, which we usually eat with tortillas because bread is a little crummy and then it makes a mess and gets in your hair and stuff. A lot of freeze-dried stuff, or dehydrated stuff, I should say. And we have a hydrator right above me. This is cauliflower and also spinach in here because my mom's probably watching and wants to know I'm eating my vegetables. And then, of course, there's things in a can. And, of course, we have candy and other things like that, which are, everybody likes to eat on Earth.
It does look delicious. But how about the experiments? Can you show us the experiments? Oh.
Certainly. I think you're thinking about experiments that these guys sent up, right? Am's experiments and Dorothy and Sarah's experiments. Yeah. And they're right here with me. So I have them here in space. This is a gap. This is Dorothy and Sarah's. and it shows a little bit change of color from when you remember it launched. It was before a little bit more red, and then we combined them in the GAP experiment. And so now, obviously, with the dye, they've changed, which means there's definitely some indication of some growth. But we'll have to see how that goes when they get returned to Earth on SpaceX coming up at the end of October.
So this is where there's a dye that changes with the acidity, and so as the bacteria metabolize, whoa! As they metabolize, it changes color. Yeah.
Exactly.
So you guys
and
have
the
a
other
question for her
experiment,
right now?
which I think.
Oh, sorry.
The other experiment, which I think you guys want to take a look at, if we can get the camera to focus, is, of course, our little Nefertiti here. Let's see if she can get in focus. Hold on. Can you see her?
She's in focus, yeah. I see a lot of dead
She's a little
flies.
scary. I think she's been eating well.
So, do you have a question about your spider here?
Yeah, I'll shoot a question. So I see there are a lot of dead flies hanging around in the silk threads. Did you get to see her actually do the jump?
Oh yeah, you know, she was in the CGBA. In her habitat there, and then also in the locker where the payload folks were able to see her with the camera, and that's what this is contained right here. But every now and then, of course, I took her and Cleopatra out and fed them, you know, by opening the plungers and opening so more fruit flies would come out. And one day I was doing that. I had the light on like this because, as you know, they hunt in the daytime, and I wanted to take a look and see if I could see her. And my gosh, I saw her stalking a fruit fly, unbeknownst to that poor little fruit fly. And she was looking at it, and she was going real close, and all of a sudden she jumped right on her. So it was amazing. And so I think the spiders absolutely adapted to space. It was incredible to watch.
Wow, I mean, okay. I'm watching you. You're very impressed. That's very cool. So the spider's able to adapt just as you predicted on. So Sarah, Dorothy, do you have a question for Sunny?
Yeah. Hi, Sunny.
Hi.
So we were wondering, can you see any differences in like how yellow each test tube is to show the levels perhaps that our bacteria has grown depending on the medium it's in?
I'm sorry, can you repeat your question one more time?
Oh, are there like different
levels of yellow? Like, can you see the different color changes, or are they all the same color?
No, they're all different. Actually, this one I just randomly picked number 5. But they all have a slightly different color. This one is really nice and orange, but some are a lighter color and some are a darker color of red. So yeah, they all have a little bit different. So I was wondering about all the data points that you guys picked, because I was wondering why they were all the different colors. And I noticed it pretty much the first time I took them out and looked at them when I was taking the pictures, that they were definitely different ones, had different colors. So you're going to see some interesting results when you get these back. And you know, right now we're keeping them at 4 degrees in this chamber, so it should maintain its, where it is until it gets back on the Earth for you.
That sounds great.
So that's what you guys predicted, yeah?
Yeah.
That's not bad, people.
Yeah.
Look at you. Both experiments came out pretty much the way you predicted. And Sunny, you are an extraordinary part of this, and we very much appreciate it.
Thank you.
Yeah, thank you so much.
So it's not just that these guys here have been hoping to ask you questions, and thank you for answering, but we have some questions from their classmates in Michigan in the United States. Here we go.
Hey, Dorothy and Sarah, and everyone in the studio. We're back here in Troy, Michigan, and we also have a question for Sunny the astronaut. Obviously, the Olympics were this summer, but we were wondering how international relations changed after we found out who got the gold medal.
Very interesting question. We actually, we have a little bit delayed TV up here. If we get streaming video, it's called KU. And so during the Olympics, we would get KU and get all of the highlights of the Olympics at dinner time, which was great. As a group, we would gather around the table and watch the Olympics. And I thought it was more of a bonding experience between all of us as we were cheering for each other's teams. Like when Japan would win and when Russia would win, we'd all be like psyched for each other. And I think that's really good for international relations. It was not, on anything bad. It was more like we were supporting each other, and got to know each other's athletes through the knowledge of the other crewmate on board. So it was really fun.
That's very good news. Very good news, because our next question comes from an Olympic gold medalist, the guy who, competing with spiders, was the long jumper who won, Greg Rutherford. Greg.
Hi, Sonny. Greg Rutherford here. Just want to ask you a quick question. If Armed Spider was my size, she could outjump me on Earth, but could she outjump me in space?
Well, I think just by mass, I think you could probably outjump the spider.
No, good. Well, that's good. It's good to know. Our next question comes from the flight director of the Mars Curiosity rover mission, Babak Ferdowsi, the Mohawk Man. Babak.
Here at the Jet Propulsion Lab, we work on robotic missions. What we'd like to know is, how can we further improve robotic missions to help human exploration?
That's, a really great question, because some people sometimes think that robotics and human spaceflight are a little bit, back and forth. There's some type of competition there. But I think robotics are awesome because they'll take the first step where we haven't had the technology developed quite yet for humans to go. And then the second thing they can do, once humans get there, they can take on repetitive tasks and do repetitive tasks such that the humans can take then the next step in exploration. So I think robotics and humans can step by step and leapfrog each other so we get further and further and understand more about our universe. So I think robotics and human spaceflight together are an awesome combination.
That's fantastic. As the CEO of the Planetary Society, this is something we advocate. I'm delighted you feel that way, Sonny. It's great. Let's change the world. So this is good, but we've got tons of questions from our live stream viewers from all over the world. So we're going to start with Pekka Ulala. What is the most beautiful thing you've seen in space? What is the biggest insight you've had, Sonny?
Well, I tell you what really is humbling is when you look out the window and you see something like the aurora borealis, or the lights in the southern hemisphere. Also, it's just amazing because it really puts us in our place that we're, the energy around us and in the universe is overwhelming and more than we can even imagine with our minds. And there's more and more for us to discover out there. And then, of course, looking at our planet, it's just pretty. I mean, it's blue, it's green, it's purple. The clouds are forming, the ice is forming. It is just spectacular. And I've said it a number of times. I wish everybody would be able to take a lap around the planet, and then they'd have a much better appreciation for it and the people who live there. And it's just so peaceful and pretty.
Oh, that's great. You are our ambassador. You are our woman in space. Thank you. We have another question. This one from Caden Kuchera. Does it ever bother you to be in such a small area, in such a confined space up there?
Oh gosh, no. This place is great, and I was here when it was a little bit smaller and we only had 3 people, and now we have 6. But we have, over 10 modules, and, it goes different directions from the front of the spacecraft all the way back to the, the Russian segment back there. It's like a 5-story house. There's windows to look out of. Everything in space is more fun. Cleaning is fun. So you don't get tired of being inside because there's always a lot of things to do. And every now and then you get to go outside, too. So that's a lot of fun as well. So, no, I never get tired of being inside here. It's great.
That's cool. We have another question from Brianna Page Henderson. About how long is your training? How long did you work to get ready for this? And what are some of the things you had to do to prepare?
You know, that's a great question. I think people don't realize that it, you know, the space station, like I said, is big, and there are a lot of things. You know, we don't have electricians and plumbers and computer, you know, IT folks up here. We do it all ourselves, and so the training is about 2.5 years, and it consists of learning about the U.S. segment modules, the Japanese, the European, the Russian. So that means a lot of travel around the world. Learning the Russian language also, because we fly up in a Russian Soyuz vehicle. We learn about how that spacecraft works. And so the training is pretty extensive on skills based, so we can be able to do all that plumbing, electrical stuff, water stuff, science stuff. So it's a lot of skills based, but it's about 2.5 years, and it's a lot of fun. That's when you get to know your crew, because we all train together.
Now, speaking of getting to know your crew, I think none of us could miss. Somebody went flying over your right shoulder. Who was that?
So that was Aki. You know, of course, he represents the Japanese Space Agency here. Him and myself and Yuri Malenchenko from the Russian Space Agency flew up on a Soyuz. But also, who's up here on a different Soyuz, getting ready to go home on Sunday, is Joe Akaba, another American, and then 2 Russians, Gennady Padalka, Sergei Revin. So we've got a sorted a sundry of people, and in another month or so, another Soyuz will come up with another American and 2 Russians. So it's pretty busy up here with spacecraft coming and going and people flying in, flying out. This is a laboratory. We're working here, so you're going to see people moving around.
But they move around in extraordinary ways. I mean, they're all flying. It's pretty cool. So we have another question from our social media. This is from Douglas Martin. What does Sirius look like when you're up there, when you're closer to the star? Sirius is a star. Or what does any other star look like, really?
So it's an interesting question, and you know, we're only about 250 miles, 400 kilometers above the Earth. So when you're thinking relatively, that's not very far from the surface of the Earth. When you're thinking about how far other planets are and stars are, so size is about the same as you would see from Earth. However, without any atmosphere, the universe is crystal clear. You can really see the 3D of the darkness that's going out there. I mean, it doesn't look like a black sheet. It's like it just goes on and on. Likewise, stars are crystal clear and they're bright. And so you see definitely different sizes, just like you do on Earth, of stars, that some are smaller and some are bigger. But they are just crystal clear. And at night, it's like millions and millions of stars. It's in some place you've been where there's no light pollution and it's just a crystal clear day. It's beautiful.
That's cool. So you guys, do you have any other questions? You got it right here, right there.
I have a question. How many sunrises do you see in a day, in a 24-hour?
So in 24 hours, we go around the Earth 16 times, so you'll see 16 sunrises and sunsets. Here in the laboratory, we've got a window below us, but it's taking some really nice pictures, and so we have it covered up with a black cover, so the pictures will come out real well. The cupola is around the corner, and sometimes it's right where the gym is, and so when you're lifting and working out, you can see the sunrise and sunset right above you. But I tell you, when we're on a spacewalk, you can really tell the difference. The heat, just the heating and cooling from the time when the sun is up and when the time that it's dark is unbelievable. Before the sun even shines on you, you can feel the heat start to generate around your body. So it's impressive, the vacuum of space, how much heating and cooling goes on out there and how much sun changes things.
That's fantastic. And I remind you, it's not magic. It's science. That's pretty cool, Sonny. Thank you so much. I'm afraid we're about to lose you. Our satellites are going to lose touch with you. But do you have any final words for the winners, for Dorothy, Sarah, and Amr? Thank you so much.
Well, of course, congratulations to you guys. Your experiments were awesome up here. I know that there were thousands of other wonderful participants in this contest, or this, I think, more of a gathering of scientific minds of our future. So thanks to everybody who participated. You guys all made the contest awesome. We're just honored to have been part of it. So thank you.
Thank you, Sonny. That's just great. Thank you so much. We'll let you get back to work. Oh, wow, that was just wonderful, wasn't it? She's flying in space, you guys. Come on. Thanks, Mission Control. Thank you very much. We'll let you get back to work as well. I mean, how cool is that?
Station, this is Houston ACR. Thank you. That concludes the event.